Welcome to the Tech League podcast.
Hello and welcome to this week's episode of the Tech League podcast. Thank you for joining. We have some actual listeners now, which is very cool. I'm Toby Sears and I'm joined as always with my co-host Krisztian Fischer. Hello. Housekeeping, as is now tradition, housekeeping first. We have an email if you want to get in touch with us. It's techleaguepodcast@gmail.com. Questions, comments, all super welcome. If you want to find us, we're on YouTube, Tech League. We're on Spotify, Tech League Podcast, and on Apple Podcasts. And then if you want us listed anywhere else, just let us know and we'll get that sorted. This week, we're going to be talking about data centers and cloud, the intricacies of both. More on the data center side, I think, is going to be the focus here. A bit more of a deep dive into the benefits and the pros and cons of both, because they do have pros and cons, both of them. But it's going to be pretty interesting. I think I'm going to get a bit more grilled than Krisztian does usually this time, because this is more where I've historically had some experience, or a lot of experience. Let's get started by saying what gives us any kind of authority to talk on this subject. I worked for many, many years in data centers, from starting in support, where I build servers, build racks, build out the networking, and interact with data center systems like the power and the network and air conditioning, stuff like that. After working in the UK in data centers, I moved to Sweden, where we had initially, I was a sysadmin and network admin for a startup, was where I met Krisztian. And we had initially three racks of collocated servers and network. And then we moved up to a 20 rack suite in Stockholm and a location, 2 racks in Amsterdam, 2 racks in Singapore. And I managed all of that. So have some background in this. You and me also, we did a lot of cloud versus on-prem calculations. We did a lot of capacity planning, and then, but for the last maybe 5-6 years, just purely cloud. Not have done any data center, but I do have a background in it, and we both have done it quite a bit. You more from the management operations of capacity planning and stuff. Me from more hands-on network planning and OS installations and stuff. So that's why we have a bit of a. You tell us yours as well, so that people can trust us.
I had some exposure to hardware before. I built, I don't know what to call those, for financial institutions. We purchased servers and racks, and we just located them in the offices for security reasons. Very local. These were like local administration tooling and back office functions for financial institutions. So it wasn't really a data center. It was more of a hardware running locally.
On-prem.
Yeah, on-prem. When I came to Sweden, that's when I became the manager of the operations team. So that was my first real exposure to running data center operations. But I was obviously more from the management side and understanding the finances and the processes behind it. But also, I really like to get hands-on, and I also built racks and cables, full racks, and everything that comes with the physical.
I taught you how to do that.
Exactly. Thank you, master. Thank you.
Okay, cool. So we have some experience in this, and we've been through also cloud to DC to cloud migrations multiple times. Yeah. Not yet been through a cloud to DC migration, although I'm sure that will happen at some point. Yeah. So
I think we should talk about multiple aspects of this. Like what does it mean to run a data center? Physically, what type of people you need for it, or what are the processes, what are the pitfalls, that you can fall into easily. Then we should discuss, should you have your own data center presence, or should you fully run on cloud? Or when should you have data center, or when you should not have data center presence? But we can go into the technical details as well. I think it would be interesting to hear, because I don't think many people are exposed to this, especially now in the big cloud era. I think there's a generation growing up who has never been exposed to what it actually means to run your own hardware, which means you just use the cloud, but behind the cloud, there's a data center. So it will be very interesting to hear the technical details as well. How does it work? And I can pitch in a little bit on how to think about it from a business perspective. When does it make any sense to run your own hardware? How you should think about it. And I think that would be an interesting discussion.
Right. So let's get started by, should we talk about what it takes to run a data?
How should we imagine, like, let's describe, like, how should you imagine what a data center looks like generally? Like, when you imagine you enter it and then describe how it looks and feels, what are the conditions in there. And then we could go talk about what units you can get there. Like if you start small, like you can have open rack or colocation.
You have a single server you can. So, okay. So for those people who have been to a data center, it's generally in an industrial area, a big warehouse style building split into many floors, usually big open floors. And these areas are super climate controlled. So they have really beefy air conditioning systems in them. They have massive power systems to go in and power all of the servers. But a lot of that is usually hidden because they raise the floor up and a lot of all of the wiring and everything goes under the floors. So what you see when you say you go up an elevator, it goes open and you walk onto a floor of this data center. Bright lights, white floor with lots of squares, okay? And then racks. And a rack is like 2 meter tall metal cage. They can also be called cages. And in those, you have slots for servers. Servers are usually like this, maybe 6 centimeters deep, high, tall, and then a meter deep. And they slide in and out into these racks. And you can fit 20, 30 of these slices into a cage. And then they usually all have power and network going in one side, and on the front they have status lights. So you can see, like, when the lights go off, and they go off, if you stand still for long enough, the lights will go off. You see them all blinking everywhere. It's pretty cool. So that's a very basic idea of what a data center is. Just lots and lots of these cages full of slices, which are these blades. They're not blades, they're the servers. And it's completely dehumidified, so you get very thirsty, but you're not allowed to take any liquids into the data center. So it's controlled in that sense. There's no liquids, there's no food. And you can get very thirsty over a long time if you're in there for a long time. What else? Very loud. Usually you have to wear noise cancelling headphones because all of these servers are blowing air through them and it can be a very noisy environment. And then sometimes you, depending on the data center, you can have these like trays that run along the roof, hanging from the roof, and they're full of network cables. It's like big trunks of these cables. And people don't usually realize, like, all of your search, websites, streaming services, everything like this, AWS and Google, everything compute related runs in these big industrial warehouses full of computers. And if you think like a footprint, I'm not sure, like I'm thinking about one that we worked in south of Stockholm. Each floor maybe has, I don't know, 1,000 racks maybe. 1,000, and each rack has, we fit 96 servers into one rack. So 1,000, that's probably not the, say 50 is the average density of servers to rack. So you got 50,000 servers per floor, and there was 5 floors. So that's like 250,000.
So it's not at all like the movies show when people are standing next to the racks and talk.
No. You can't. You have to go. Ah! You have to like shout at each other. And you will see people in there very rarely, because usually the servers, we work with them remotely. So you go and you set them up. You get them to a point where you can connect to them remotely, and then you go sit in your nice comfy office and do it. But you do occasionally have to go in there and fix problems, and you see people wheeling these trolleys around with a keyboard and a mouse and a monitor. You just plug into the servers and then you can fix them. That's generally how it looks and feels. Usually you have to go in through security, you have to check in, you have to sign in, show ID, because some of these facilities are super very secure. You don't like, because it's got personal information on there. They're doing financial stuff.
There's a physical security layer as well.
Yeah. But yeah, it's like what I was trying to get at is most people, I think, don't realize that there's so many of these around the place. Like when I lived north of Stockholm, I would walk past one every day, and you wouldn't know that it was a data center. It just looked like another industrial building.
It's so funny. I just realized I found this website called datacentermap.com, spelled in the English, or sorry, in the American way, datacenter map.com. And I realized that I have one just like a few hundred meters from me. I didn't know. It's a low tier. It's a low tier data center, but it was the first one that was classified with some green, totally green energy in the world. I didn't know it exists. I know the place. I know there's a small building there. I didn't realize it's a data center. And then it made me wonder, like, how many are there in Sweden? I think I found like 67 or 69 or something like that. Very many that you would wonder. And some of these are huge, obviously, like the ones that we worked in. But there are tiny ones as well at lower tiers. So it's very interesting.
I've been to quite a few actually, different types and of different tiers. So I worked in the tier 2 or 3. One in the, again, to explain a little bit more, tiers are based on uptime. It's like the SLA. So a tier 4 data center has redundant power, redundant cooling, redundant network, and it guarantees a certain uptime. The one we had in Amsterdam, the one we collocated in Amsterdam, that had power from the grid in the Netherlands, but it also had a dedicated line coming from Germany, just to guarantee that kind of redundancy. So that's the kind of level they're talking about. And they also have like submarine engines in diesel engines in containers for like, so that's not the first thing. The first thing would be they have these massive battery banks in every data center, or every one over a certain tier. I think it's tier 3. They have massive battery banks that can run the whole data center for a few minutes, just long enough to get the backup generator started, and then the backup generators can run the data center until the diesel runs out. So that's a good, like if you're looking around trying to find a data center, look for these shipping containers with exhausts, and then you think that's a generator, and it's a good chance that that's then a data center. I've been to some really interesting ones though. There was one in London that was in a skyscraper, so like it was just a skyscraper full of servers. That was cool. And then there was another one in Stockholm. I went to the one, I'm sure maybe people haven't heard of it. It's built into an old bunker, a World War II or a nuclear bunker. So you go through these big, massive blast doors down. There's a couple of diesel submarine engines and the old like internal of the bunker. So you think like where the real inside through metal doors was like a control center. They've built it into the crew compartment of the bunker. And then the main part of the bunker was it wasn't very big, but it was prestigious. So like the Pirate Bay and people like that were there. And it was filled. It wasn't very big, but it was maybe 100 meters by 100 meters, and it was filled with racks. And then on top of that was suspended walkways, and then a meeting room at the top. And they said they wanted it to feel like a James Bond layer. It was very cool.
That sounds super good. I think you can visit this data center, right?
I think you can. Yeah, I went there because we were in talks to host their other data center, so they took us to that one. So
you mentioned 4 tiers.
Yeah.
So the tier 4 is the highest availability.
I think some people they might advertise tier 5, but it's just a gimmick. I think
it's just more redundancy, I assume, on top of it. So how does the redundancy manifest for you as a user when you're building the rack?
Okay, yeah, because you can tell. Well, if you're building a rack and you have your empty rack, you will notice if you have a good data center, you'll have power at the top and power at the bottom. It's 2 power inputs from different circuits. So you generally, when you're designing the rack, if you want power redundancy for your servers, okay. So how does higher redundancy manifest in how you see it in the rack? So you have usually when you're given, depends on the situation, but say you're renting a one collocated rack, and by collocation we can probably talk about that a bit later, but you can rent suites, which are a group of racks. You can rent individual racks, you can rent half racks, and you can rent individual servers. But in this case, let's say you have renting a whole rack, and usually that's just an empty rack that you can mount equipment within. If you're in a data center that supports redundant power, you will have 2 power inputs, and usually you mount them at the top and the bottom, or you mount them however you want, but you'll have 2 power bars essentially. And then you want to get server chassis or network chassis that support dual power, and you plug one into each circuit. And that way, if one of the power circuits goes down, the other one can keep everything running. You do run it. Sometimes you have to change one power supply, And the good thing about these is you could take one out and keep the other one can keep running, because power supplies do break occasionally. You nearly got shocked by one, didn't you?
Died.
Yeah. So and
There's
like
a lot of dangerous things here.
there is a lot of danger, but the cool thing about a lot of these servers, say you buy a Juniper router, and it has dual power or even 4 power, but like they're usually super modular. You just like do a clip and you can slide the whole thing out. You get a new one, you slide it in, clunk, plug it in, and you're all fixed. And that harkens back, I think, to the mainframe days when you could like live swap components in most things. You can do a lot of server hardware is designed to be hot swappable. So you can have like another thing we haven't talked about types of servers. We can use. I talk about this one. So they're usually
measured in units, right? Like
units exactly. Units. So it's called 1U, 2U, 3U, 4U, and you can get
the height of the equipment, right?
Exactly. So one standard height is 1U. It's like 5 centimeters or something. You get 1U blade, a 1U chassis, and this slides into 1U. But you can also get, say, what we ran was super micros, like that had 3U, and they had 8 individual blade chassis within them. And that's 8 individual little servers that you can slide in and out. Now the problem comes with how do you get redundant, say you want redundant power and you want redundant network to each blade. Usually the redundant power is handled in blade chassis by having redundant power for the chassis itself, and then it powers all the blades, and then you can swap those out. But for the network, you have to have 2 network cables to every blade. So say you have 8 blades in 3U, so the 3U is like 15 centimeter depth. You have to get 8 network cables, and then for us we had a separate network that connected to the IPMI, which is the onboard management for these servers that allows you to reboot them, log into a command line console or whatever through another network.
So there's a network, like an admin network layer.
Exactly.
Or like a network. It's not a layer. It's literally like separate cables going into the chassis. It's
like a little computer on the chassis itself that runs a little operating system that allows you to mimic having a keyboard and mouse connected to it, or reboot the chassis and do stuff and monitoring and things like this.
And then each actual server also has 2 network cables going in, and that's where the actual data flows. It's not the management interface, but it's the server's network interface. Exactly.
So you see, there's already a lot of things to think about when you're building out a rack. So if you want to build high redundancy and you don't want things to go down all the time, you want 2 network cables. So you want some sort of bonded network interface in the operating system, so that if one dies, the other one carries on sending traffic. You talk about redundancy all the time. So it would be 2 network cables, 1 for an IPMI. So it's 3 per.
That's a lot of cables. And then we have how many in the rack?
How many in the rack? So it's
10 or?
No, 20. I think. No, it was 10. Yeah, I can't remember. But it was quite a few, because we had to split it into half. We had to split it into half racks because, and I might be getting all the numbers wrong now because it was quite a few years ago, but we had to split it into half racks because not only do you have 2 network cables coming off, you need 2 switches, and each switch takes up 1U. So you have to put 2 switches there, 2 network cables down, and then you can only fit a certain amount of network cables into a switch. I think it's 48. You can only do 48 servers per switch, so then you need 2 switches per half rack, and then you have to do all the cabling. Lots of work designing it as well. Okay, so to summarize what we have so we have racks. Racks are just empty cages for putting server hardware in. They come in standard units, and there's like 1, 2, 3U size. They slide in like this, and then you plug them in with cables, power cables and network on one side, and on the other side is hard drives and stuff usually, so that you can access them on the front. So that's usually it. And then the data center will handle the cooling, so it cools the air. So you have hot aisles, you have cold aisles. The cold aisles, you put vents in the floor, and it blows cold air up. And then the servers, they pull the air through, and that cools the server. And then it goes out onto the hot aisle.
Yeah, I remember like the racks or cabinets that we used, they had a chimney on the top.
They were a special type. They were non-standard, but they still had a cold aisle in the front where the remember I said that the floor was raised. Under the floor, they blow all the cold air, the air-conditioned air, and then they blow it up through the holes in the ground. You have you replace the square raised floor in front of the rack with like a grill, and that lets the cold air up. Then it sucks it in. Those racks that we had, they were designed to hold more high-performance servers, so they would then suck the hot air out, so that it was more efficient. The standard way is just to have a hot one at the back.
So the limitation on how many servers you can ram into a rack is not just the physical space,
power,
the
heating, and network. So yeah, the power, because you can only get well, first of all, you can only get a certain amount of power per rack. You pay for it, and data centers will only support up to a certain amount depending on the data center. Where does the network cable go? So the network cable usually goes to, again, this depends on the scenario we're talking, your one rack. Maybe you buy managed internet from the data center provider and they drop a cable in that then plugs into your switch, and then you can plug all your servers into that, and then you have like managed network there.
So that means they are providing the network connectivity which reaches my rack, and then I can distribute that network connectivity within my rack any way I see fit.
Yeah, that's usually the simplest way. If you want more control, and what we usually did was we would have a network or 2 network racks within our suite of 20 racks. And a suite is like a closed off lockable enclosure within this. Like, remember I was telling you, big floor, imagine metal walls with a door. And you go into that door and you can access 20 racks. That's what we had. So
that's even more physical security for your infrastructure, so nobody else can get close to your servers.
No, and it goes right up to the roof, so there's no way in. The data center staff will have a key, and you get a key when you sign in. So you sign in, and then they will hand over your key once they trust you. In that case,
the individual racks are also protected.
They can be, not always, but they usually have these. It depends. Like in our suite, when we had 20, we had the physical lock. Then we didn't have locks on the individual cages. But if you are renting a cage in a rack in a shared area, you have a key per rack usually. So you walk past these racks, you can see what's in there, but it's like a locked cage. You can't get into it.
But I can put a stick in it.
Yeah, you could. You could put a little stick through the air holes and then press the reboot, but you would be banned from the data center and then you would never come back again. But you could do some chaos engineering while you're there. That'd be pretty fun. But back to your question about the network. So the easiest way is just to get managed internet or managed network from the data center.
So we had the managed network cable in the rack for the most basic use case, but then I have to pay the data center for that network, right?
Yeah.
But what if I want to have my own independent network? What do I need to build then?
So that's pretty complicated. You need a network engineer. So the internet, most people don't know this. The internet is just a bunch of routers all connected together with fiber optic cables and trust. There's been, like in the past, there's been issues. I think it was in India where a network engineer started advertising the ASN numbers of Google and blackholed all the Google traffic in the region. I don't know if we have time to properly get into like how BGP works, but what it does is it has a list of ASN numbers, and ASN numbers are registered and have a certain IP range, and you can...
Okay, so if I have an ASN number, then I can get IP blocks allocated to me that only I may use.
So first you need to get an ASN, and you have to go to a independent organization like RIPE in Europe, and they assign ASN numbers. And you say, okay, I am this company, I want an ASN number. They're like, okay, fine. And then you say, I want a block of publicly available non-internal, because there's the RFC 1918 addresses that are internal. I want a block of external IPv4 or IPv6 network IP addresses assigned to me and this ASN number. And they will then assign you a group of IP addresses. And then what you can do is you install a BGP capable router in your rack. You then contact peering providers. And a peering provider is an ASN number company that lets you advertise your ASN number through them. So we use Telia, for example, and Telia, we said, okay, they gave us a cable. Well, we talked to the data center and we said, we need a cable run from the network room. Telia said that they've given us this port in their router and we need to we need a fiber optic cable pulled into our suite, right? And then we plug that cable into our BGP capable router. We then establish a peering connection with Telia and say that we're advertising this ASN number.
So from that point, you can address this IP. Like if you try to address any IP in this range, it will reach our router in our rack.
Eventually. So the way BGP would work is, say you're on the other side of the world, you say, I want to go to this IP address, it would find out. It would just send it out, and then it'd get to the first BGP capable router, and it would say this ASN number is via these ASN numbers, and it would send the packet to that, the next one on the list, right? And it would go through all of that lists until eventually it would hit our BGP router, and then we would be able to do something with it. And that's the whole internet is just like a spider web of ASNs.
And you mentioned this like network room.
Yes.
That sounds like a magical place in the data center.
It is a magical place. They have one usually on every floor, and these network providers, these peering providers, they have just network equipment in there. That's it. Just like switches or routers with SFP connections that allow fiber optic connections into them.
So it's like that's purely network equipment just for the connectivity of different networks and out onto, including the internet itself.
Well, the thing is, as soon as you have an ASN and you have a block of IP address, you are the internet. There's no out to the internet. The internet is just a group of these network rooms all connected together.
But then it could be a bunch of nodes between the source and the destination when we're actually doing many of these network rooms involved with many routes.
So it could be. The good thing about BGP is it will find the shortest route.
Yeah.
So it will compare, but it doesn't have any idea about geography. It only cares about the amount of ASN numbers. So it could go around.
That's why we have TTRs, like how long.
They'll die because they will go off in the wrong way and then they'll die. Okay, so like proper tangent there about BGP and network connectivity and stuff.
Let's not go in. Maybe we could have an episode where we explain that in detail. But I was just like, because you mentioned fiber cables, like typically within a rack, you're not using fiber cables. You're using the fibers between network equipment where you need high bandwidth, right?
Yeah, this is again part of the planning you need to do when you're designing a suite or a rack or something. You have to decide how much bandwidth does each server need. You have to make sure that you've ordered the correct size ports, the correct bandwidth capable ports for each server, and then you have to buy the network switch that has a good enough bandwidth, and not just per port, but the burstable, the trunk port up to the main network thing. Because I was going to mention that like as soon as you have like if you're running your own internal network, you have BGP on the edge usually, which is the router, and then you have OSPF internally. We did the BGP all the way down to the servers. Open short.
We haven't introduced these terms.
There is different types of it's different types of networking protocols. OSPF is open shortest path first. It's sort of like it's like an algorithm that will work out within a network which way is the shortest amount of hops to well, not hops, but like there's the weighting per path. And I'm a bit rusty in this, so I haven't checked it in a while. But I know what we did was we wanted to do, when we built it out, we built BGP all the way to the servers. So the servers would advertise their own BGP ASN number, and then that would propagate within the network, and then externally we wouldn't share that, or we would block that. But
I wanted to ask about because you mentioned the fiber cables and the complexities of that, or like how, because that's not very common for people to use, because Cat cables, Cat 6, Cat 5, these are very common in households even. When you connect to networks, like you are familiar with the Ethernet cable, but fiber optic is a whole different world, right?
Yeah, you need special. I mentioned before SFPs. Usually you get a switch with just like sockets. They don't even look like network cables. They're like these little metal sockets. And then you have the module that you clip in, and then you plug the little fiber optic cables into it, and it reads the light signals on the end. So it's a lot, there's quite a bit of complexity involved. And one of the reasons you don't usually use fiber optic per server is because they're quite fragile. And like even a little break will ruin the cable, and they're very expensive. But so what
So
people,
the SFPs are optical to electronic conversion in a
yeah,
sense.
that's a good
And
way of putting it.
vice versa.
Yeah. And they also come in speeds. So it's 10 gig, 1 gig, 10 gig, 100 gig SFPs. So this is something you have to also think about if you're designing a rack. You have to think about how much does each server need in terms of bandwidth. And then is that going to be consistent bandwidth or is it bursts? And can you get away with a lower trunk? So you usually have individual cables going into a server, into a switch, and then you have a trunk which goes from the switch to the main router, which is like the backbone of the network, and then that spreads it out to each switch, right? And then or it goes out to the rest of the internet. So you have
So
to
there's a whole lot of thinking that needs to go into
a lot of planning as well, because it takes a lot of time to get
building
it
a
all
rack.
set up, and then changing stuff it's not like with the cloud where you just delete it. You've bought physical hardware, like an SFP costs, I don't know, a few $100 or something, and like you've got the wrong one, now you have to buy another one, or you bought the wrong hard drives and they don't fit. Those cost money. Everything costs money, and it's not a shutdown and you don't have to pay for it anymore. Now you have a physical thing you have to hold. So there's a lot of pre-planning involved.
So that means I have to plan the physical layout of the rack. Do they actually fit in the rack? I have to know how much heat they will produce. Can the cooling system handle that? So I'm sure the data center has some limitations on that. Then the power is a limitation, right? So that there's a power limitation in terms of how many amps you can draw from each power bar. And you have to design it in a way that if one power bar fails, so that means one independent power supply fails, the other one should be able to take all of the servers full load.
Yeah. Because that's actually a common mistake. People over subscribing on one, not thinking about the failure scenario, in which case one goes down and then the whole load goes to the other, and you blow the fuse because you've got too much power draw on the other one.
And then you also have the network design you mentioned, like the bandwidth design, like per server, per chassis. Then combine all the chassis combined, what network traffic they require, and that defines what trunk you need.
And and then you have to think about how much of that is going out versus how much it's called north, south, east, west traffic. East, west traffic is within your suite network, let's say. And then north, south traffic is out to the west of the internet and back. And you have to then, say you have a lot of cross-server communication, you want to make sure that all of the network equipment can handle that. And then maybe you don't need so much of a big external router. You can have a beefy internal router. And
maybe we could dedicate an episode for this topic. It sounds like
I'm a bit rusty.
But let's zoom out now for this discussion, because there's a lot more to unpack. So now let's say we have our own little suite with a bunch of racks, a lot of servers in each rack, network equipment, we have internet connectivity. So what drives the cost of this whole thing? So do you think people is the biggest cost?
I mean, the thing with data centers or building out a data center suite or something is a big initial cost outlay in terms of hardware, because they are can be quite expensive. They're very expensive for personally, but not that expensive from a professional point of view because it's tax-free and stuff.
So let's say like a BGP router, what range is that?
I have no idea. I would have to look it up, but you're talking probably like tens to hundreds of thousands of dollars for a good one. It's a big broad range. I can't remember off the top of my head, but it's a lot of money. And then you have to spec them out the way you want. You have licensing for the operating system on them. You have licensing for certain things, like, can it do certain features? Like they have software licenses that let you do BGP or not, or peering connections or not. And then you probably have to buy all the SFPs, the specific SFPs you need, the network, the fiber optic to electric converters. You have to buy all the fiber optic cables. You have to buy anyway, there's a lot to buy even before you even get to buying hardware. And then when you buy hardware, you have to think, how much do I need now? How much am I going to need for the next year before we do another round of buying servers? Because this is another problem with buying very static. That's the problem with data centers, very static.
If you have many customers that can share the hardware, then
it's
better utilization.
Yes, that's why.
But that's what the cloud is.
Exactly. That's why the cloud became a thing. It's because they can build out these massive data centers and they can kind of guarantee good usage across all of the hardware. But like, there's this term in being a sysadmin called blowing hot air. And that's just servers that are running, doing nothing, because you want them usually up and running so you can access them. We got around that by using the IPMI to turn them on and off. But so usually when you provision the suite is on and the servers are running and they have a lifespan, the hard drives have a lifespan. So if you're not using them, you're wasting money, both power and the hardware itself running out of life. So this is capacity planning is super important. And then, so you have, what I mean by static is, say you get the capacity planning wrong and you have underbought, and you have people in your teams, they need 4 more servers, you only have 2, and it takes 3 months to order servers. It's very static.
Is that a typical time?
It depends on the time of year you're buying and problems with, I don't know, supply chains. Because I worked as well, when I worked in the data center, I worked in procuring hardware for the data center. That's one of my jobs. There would be international situations that cause a lack of SSDs or certain power supply components. So the available capacity of servers would go down, and then you'd have the longer queues. You'd have to wait longer, which was a nightmare for capacity planning as well. But that's what I mean by pretty static, in the sense that it's not elastic. Like you can't scale up and down as you want. You have a physical amount of hardware, and that's it. That's why I like
scaling down is also complicated, because secondhand selling the hardware is
that's
you only
hard.
get a fraction of that price.
Yeah, and I mean, if you want to scale down the hardware and like sell the hardware, exactly. You can do it where you, like, if you want to turn off unused servers, that's possible. But then you have you have to do people hours to implement a system that will do that. It's not as like well understood as, say, a cloud scaling optimization. It's like we're going back more to like having to send signals to an IPMI via a private network to shut stuff down.
Okay, so what team do I need to operate? Let's say I have 10 racks full of servers. I have my network equipment, my own ASN number. What team do I need to build, or like what team do I need to operate this?
The first question I would ask is, when is the handover? What do you expect from this team? Do you expect a fully functioning OS with a certain level of stuff configured, or are you expecting, I don't know, a Kubernetes cluster on top of it?
No, let's say, like, let's start with the easier or like basic level. I want the servers to be up and running with an operating system running on them that I can reach via the internet. SSH into it.
Okay, then you need a proper operations team. It would be, let's talk in terms of engineers. You want at least 2 sysadmins and 2 network admins, and I would say 2 because you're going to need on call for this, depending on how uptime it needs to be. But like, you don't want individual points of failure. And ideally they can cross pollinate in the sense that you can. A lot of the time, a sysadmin can also do network, and a network can also do software. So the network engineers need to have experience with peering, configuring BGP, depending on how you want to do the internal network, OSPF or BGP. They need to be able to physically cable and configure network hardware. The sysadmins, the sysadmin, DC admins, I call them, they need to be experienced with, say, Linux, server hardware, and provisioning. So you want 2 network people to build out and manage the network. They can also help with like automation of provisioning new racks and whatnot. And then the 2 sysadmins should take it from it's built. Well, the network is built, and then the 2 sysadmins can build the racks, plug the servers in, and then configure them and install the OS. And then once it's up to the spec, you hand it over to the people you want. And then you're going to have monitoring and stuff on top of that. But 4 people, I think.
Team of 4.
Team of 4 for, like, I'm thinking 20 racks now. Like we ran, but the thing is, it doesn't scale very well either, because we had a 3 racks and we need 2 people. We have 20 racks, you can have 4.
If you want to have on-call for any system, I would say, from my experience, you need 4 people regardless.
Yeah.
Because of vacations, and if somebody gets sick, then you still need people on deck. Then let's say your 4 engineer team. What's the maximum of servers that they would be able to handle without scaling the team again?
Depends how good they are.
What's a typical server to person ratio that
you would
be comfortable with?
It depends. Again, this is a hard one to say, because say you're provisioning them all exactly the same and you're just throwing them into a Kubernetes cluster that someone else manages, then I would be happy with, say, 1,000 per person, probably. Because then it's just maintaining the OS, fixing hardware issues. It's fine. But as soon as you start introducing, like, having to build out tooling and stuff on top for other teams, that takes away from the ability to maintain a bunch of servers. Maybe 1,000 is a lot. I've personally done 400 or 500 by myself without problems.
And then how do you manage, like, because you mentioned that the hardware degrades over time. I assume different components degrade at different rates. How do you handle those situations?
In that case, it's quite funny. You see with hard drives, for example, they have a very high failure rate at the start and very high failure rate at the end. So they go like this.
People who are not watching the video feed that you show.
Oh yeah, sorry, it's like a U shape. Yeah. That's a good point. You want to have spares for everything. So that's more capital investment you need to do. And multiple spares for everything. You want all of the engineers that are building on top of your hardware need to understand that one of them can go down without warning, and their software should be able to handle that. Because then you can just take it offline and fix it. So you need new RAM sticks, or you need a new hard drive. And usually, for example, for a new hard drive, you have RAID configured. So like you can just plug the new hard drive in, it will self-heal. Or if you need new RAM, you slide the blade out.
Interruption.
Yeah. That works. Yeah, if you've designed it well enough, and if you design that level of redundancy, which costs more, then you can have self-healing stuff. If it's something like RAM, like you've got corrupted ECC RAM or something, that's from like cosmic rays flipping a bit. No, that ECC corrects that. That's why ECC
to a
is
certain degree.
Yeah. But say you've got a dead RAM stick, you have to take the blade out physically and replace that. So you need spares for all these things. And if they're pretty new hardware, you have to do RMAs. So you have to return and get a new one because they're usually under warranty. So that's also something you have to worry about. You have to have an RMA process for, say, hard drives or RAM or server blades or whatever.
But for me, as a user of either a data center or a cloud, it doesn't make much of a difference. I have to write my software in a way that it tolerates individual server failures, right? Yeah.
Yeah, and then when you're building, the people building on top of your servers, you can be very clear with the redundancy levels. You're like, it can handle a failure of this, and this, but it can't handle a failure of this. And you can give them a kind of rough SLA of what you think it is. But they should still design it. I always said to people, please design it so that I can take it out of the rack, one blade out of the rack, or two. So have 3 of each, because then you can take 2 out, and the third one can handle it. Do you know what I mean? Because I have had situations where 2 have failed. That's very rare. 1 is quite common. 2 is quite rare, but it does happen. 3 is super.
And if you bought because you mentioned the characteristics of the hard drives, for instance, that they tend to fail in the beginning. So typically you buy a lot of hardware at the same time. That means that they will all fail. A lot of them will fail at the same time at the end of the life cycle or in the beginning of the life cycle.
You can get bad batches that just all fail at once, and you're like, oh god! And then you just have to take them all out, change them, and reinstall the whole lot.
When I buy a server or a bunch of servers, how should I imagine it? Like, do I buy that myself and then I bring it to the data center, and then or how does this work?
We would go through either directly to, say, Supermicro, which is a server provider, and say ship them to the data center. And so you buy 50 servers, they ship them in boxes, cardboard boxes, to the data center on a pallet, and then you go to the loading room in the data center and you unpack them all, you put them on a trolley, you wheel them up to your suite. You can also get the DC, usually have remote hands. So that's like the concept of, and I did that for a long time in the data center. I was the remote hands. People on site who can do things for you, but you pay them by the hour. So you can get them to unpack it and move it up. Generally, if you have people who are aware of the hardware and your network, you generally want them to do the installations because they're more aware of what to do. I've had bad situations where people don't follow cabling standards. The main issue with that is
you are quite picky with the cabling.
But I mean, you have to be, because say, like we were saying before, you've got 9 or 8 servers in a small space, and there's a bunch of cables going in, and then the RAM dies in the middle of one of these. You have to move all the cables out the way to get that blade out to be able to repair the server. And if you haven't done it in the right way with like the right looping and stuff, there's not enough gap to get the blade out. So you have to design the cabling in the right way so that you can actually remove the hardware.
So you could get a server stuck in a defunct state and not being able to access, because that would mean that you have to stop fully functional other servers if you design.
Exactly. You have to, like, say you've done it wrong, you have to unplug the network cables for a different server to get that blade out. Then you're killing a perfectly working server that might have production workloads on it that need to be running. And I mean, it could be that like maybe you have to unplug two next to it, the one you want to get to, and those two are the other two of the cluster that's running 3. So you just can't pull it out. And then that's just a dead blade you can't do anything with, and you're wasting money.
Yeah, so you mentioned like a lot of different cost items already, right? Like you mentioned that there's some upfront cost too. I assume like that's a rack space that I have to rent every month. Then I have to pay for the network connectivity you mentioned the Telia or like the peering.
Yes, you pay. Yes, you do. Yes.
Pay for that. I have to pay for the ASN number, I assume, and the IP
I think that's a yearly
range.
Yeah.
That's a yearly cost. Then probably the most expensive is buying the hardware, of course, but that's a one time. And then can we calculate with like 5 years lifespan of each?
They usually recommend 3 years. So you're supposed to cycle them out every 3 years. I think that's a bit wasteful, and you can probably get away with more. But I think they usually ship with like 3-year warranty or something like that, and you want to keep them in warranty. So you should plan as well as capacity expansion. You should plan to rotate all your hardware every 3 years.
So if I use the 3-year example, that means the hardware cost that I initially invested in, like every 3 years I have to reinvest, or every year 1/3, because I have to start replacing the servers. And then power, that must be a huge contribution.
Power and cooling, yeah. And cooling, I think, is included in the colocation fee.
And then I have the cost of the team, I think, which is very, very region dependent, or it can vary very much. But these are the different cost items that you have to consider. Because I want to transition into discussing, should you build your own data center presence or not, or should you just use cloud, or when does it make sense? But from what you said earlier, there's a pattern emerging here. If you have very bursty traffic, or your traffic goes up and down seasonally, let's say when one part of the season, let's say during summer, you wouldn't need 100 servers, but during winter you need 200.
Then you have to have 200 all the time.
Yeah, so you have to 200. So it probably doesn't feel like it's a right choice. Then we would recommend using cloud resources as a small company. But if you reach a certain point and you have a stable base load that you always have to have, then in that scenario you could use a data center. But the question is, should you?
I would say outside of some edge cases, and by edge case I mean I met a guy recently who he had a company that they built on-prem, and by on-prem I mean like on the premise of hospitals, GPU clusters for LLMs. That makes sense because you don't want the sensitive customer data going out to these LLM providers or whatever. Or say you have this kind of government requirement that you must store all of X or Y data in your own owned hardware, then yes, sure. Outside of that, I can almost never see a situation where a well-designed cloud platform doesn't beat your own every time. I don't see a situation where you would need it.
Because the cloud's flexibility, because it's someone else's hardware, and I can stop using it if I don't want to.
But it's not just the scale of the flexibility of it. It's the mental cognitive load. It's the amount of administrative load. It's these hidden costs. The fact that you might not be able to scale up is one of those, but there's also like the fact that they're so big, these hyperscalers, is they can buy hardware super cheap. They have power super cheap. They have all of these things super cheap because of the scale, that they can provide very comparable and sometimes cheaper alternatives for you.
From my point of view, from a compliance perspective, you might be forced to use your own hardware where you can't use shared resources at all. This would be gambling regulation in the US. Like you have to have on-prem, like within the building or within the state.
I've done this. I've been in the industry, and what we did then is we had edge servers in the casinos, but they talked to backend systems in the cloud that could scale.
So data is stored in the casino as well, but also
if you want to do
cloud.
non-customer related, it's more like, you're pulling the odds and stuff. That's fine. I still think there's very few cases in which you only need to do just on-prem hardware.
I have another use case that I think where it could be important to run your own hardware, and that would be if you need to guarantee certain response times, and you have to be low latency, high performance, because in a cloud environment you're always sharing or running on top of a virtualization layer that is not as predictable as running your own hardware. So you can't optimize your source code to the hardware if you don't know what the hardware is, or you don't have controls over it. I remember running our own hardware where we for instance, pinned the network interrupts to a certain CPU. Like these things, these type of performance optimizations you cannot do in the cloud environment. So in that case, I could see, but this would be high frequency trading or very special use cases.
Well, we did it with ad tech, where we wanted super low latency for the last mile. And by that, you mean like to the customers, like you and me sitting in our houses. And by controlling our network, we could control who we were pairing with, where we go through. Like we picked providers that were very well covered. So say you pair with someone who provides the internet for most houses in Sweden, then you have a super quick hop through to their network and then super quick out. You could do a lot of optimizations like that. And if your core business is reliant on something like super fast, low latency, last mile that requires these kind of tweaks, then sure, totally. But I still think in today's day and age, that's not the majority of businesses.
Yeah, typically you don't need it, I would say.
And the people who think they need it don't need it. I would almost always argue that this is the case. But I have seen genuine use cases for it. Like the hospital example.
I could also see use cases where you need, let's say, 1 or 2 racks in your industrial facility, like a factory, just to be close to handle robots. So you don't want to be down with your robots if AWS is down, for instance. But I know AWS also provides this, like, and we're sort of going into the hybrid solution, because the use case that I mentioned where you could run your base load in your own data center and the excess capacity you buy from the cloud provider. But I know but you can do the opposite as well, like where you have a fully cloud presence and you want a local presence. AWS, I forgot the product name, but they do deliver you a rack, and it runs a few services like EKS and databases. I think they can run locally. So you could have a physically local cloud if you wish, like, right? It's a bit weird to say that, but it's on-prem cloud.
This is they did a very good job with the marketing to make people think cloud was different, but it isn't. It's just you're running on someone else's service. That's literally all it is. It's the same with serverless. Is another branding technique, because it doesn't make any sense, right? But serverless is just functions as a service, right? And this is my caveat when it comes to cloud versus on-prem. You can be the best, you can do it really well on both, but you can also do it really badly on both. I think it's easier to do it well on cloud. And
easier to fix the errors.
And to iterate and fix as well. And the caveat being, if you just run EC2 machines and you're not doing any cloud-specific optimization, like changing to event-driven or like scalable workflows or any workloads, maybe the costs will be more than the data center. But if you tailor your architecture to be more cloud-specific, then you're almost always going to be underneath the cost of a data center, if you include the hidden costs.
Yeah, I have done this calculation a couple of times in the ad tech industry, right? So every year we had to look at the numbers. Does it make sense to run our own hardware and not? And if I just purely look at the sheer numbers, then we consistently seen that the data center was 30% cheaper than the cloud, equivalent cloud resources, I should say. But the effort that went into that, full team, automation tooling, all that jazz, has taken away those brains from building what the core business was at serving. Right? So the opportunity cost is not factored into that. And also the flexibility. Let's say AWS comes out with a new service, managed Kafka, which they have and they didn't have before. And then you had to run, let's say in the data center, you had to run your own Kafka cluster. That's another team. You have to run a full Kafka cluster. But then as soon as AWS comes out with a managed Kafka solution, you can just start using it. You don't need a team. You don't need anything. So long term, I would say the cloud always wins, because the cloud is just another huge data center. It's obviously multiple data centers that has the economy of scale, and you will never be able to beat that.
But also, if you think about it from a core business perspective, their core business is providing compute services. And so they have people that their whole job is making really good compute services, and also super high uptime compute services. This is something I haven't mentioned, is like the more uptime you want from your own data center, the harder you have to work at it and the more money you spend. But like, if your core business is not providing compute services to other people, why are you spending all of this effort on building out what is essentially your own cloud? Because that's what it is. And like, say Amazon has hundreds of people and their job is just to make a highly available, efficient compute platform. They just pay them.
You can't compete with that.
No, you can't. You cannot compete. And again, is those customers or those people that have companies that have a regulatory requirement to have on-prem stuff, sure, that's fine. But you can still probably do hybrid approach, like you were saying. And hybrid works really well in that kind of situation, because I've seen the situation where people will read the regulations and they will be very dogmatic on it. It will say something like customer information needs to be stored on your company premises. Fine. And they're like, okay, we're running all of everything on the company premises, but that's not, you don't need to do that. You just need to store the customer information, and anything that's related to customer information. You want to do other things, you can do them on the cloud. It doesn't matter. So I've seen cases where hybrid has helped companies a lot.
Okay, so we can conclude that it's almost never a good idea to run your own data center.
From experience, and someone who has had over a decade of experience running this stuff, and it should be my, you can see a lot of tribalism when it comes to this topic. People are like, but I spent my whole life working with data centers. Of course data centers are needed. Are they? They are, obviously, but not every company needs one.
Yeah.
And I am pragmatic in this, in the sense that I think I'm lazy. This is the point. There's a lot of work around a data center. So I'm like, do I really need to do this? No, just pay to do it. Someone else to do it for you.
Pay someone else to do it for you.
Yeah.
I agree. Most of our listeners will probably use cloud. How does the cloud terms availability zone, region translate into this physical data center solution?
Well, I don't have like actual on the ground knowledge of the hyperscalers or the clouds themselves, but my assumption is availability zone is a data center, is a actual physical data center, and region is a group of data centers within an area. So the EU North 1 in Stockholm would be a data center north of Stockholm or within Stockholm. EU North 2, I don't think it exists, but EU North 2 would be another data center within. So they have all of the data center level, tier 4 level redundancies of power and network and everything, but they also have really tight interconnects, like you were saying, between them in terms of network. That's how I would see it. That's how I see it in my head when I see the availability zones and regions and stuff.
So if we bomb one data center, it will kill the availability zone probably. Yeah.
Now, if you see that an availability zone has gone down, DC has gone down probably, or something. Like I've seen outages of whole DCs due to network misconfigurations of the core routers and stuff like this. It's usually something like that. I've seen horrible ones where like there was an issue where a brand new built data center had really nice battery banks and diesel generators and stuff, but fuse had blown and all of the power for the data center went through this one fuse. It was badly designed, and so they had to shut the whole data center down to fix that one fuse. And I see
tier 1 then.
yeah. I saw another. There was supposed to be a tier 3, but I seen another one where all the air conditioning started failing in the data center. And that is bad because the amount of heat these servers generate is insane. And I don't think people realize it. Most of the power I think that a data center consumes is in cooling. I'm not sure if that's true, but I think most of the power. That's why they built these data centers up in like northern Sweden and stuff, because they use the environment to pull in the cold and cool the data center.
the little data center that I mentioned that is fully green certified, I don't know, the world's first in my little town just north of Stockholm, they actually feed the heat of the servers back into the communal heating system.
You see that a lot now. Yeah, it's very cool.
Yeah, so they try to use the waste heat to heat houses, which is amazing.
But this is another I think it might be that data centers are more in the public eye now because of AI and these talks about the water usage and power usage and whatnot. So it will be interesting because I think I've mentioned it before. Because of the staticness, it takes a while to provision. So we set up systems before where you put say you want to provision a new rack, you put it in, you put the network switches in first, you run a fabric script or whatever to configure the switch, and then you put the server chassis in, you wire them, cable them, and you plug them in, turn them on, and they install themselves. That's one of the better systems I've seen. It's probably similar to what like Google and Amazon and stuff like that do, but like still, you have to build a building. You have to put in the right cabling, the power, the air conditioning, the network, segregate it into levels, put the racks in, get the hardware in, install the hardware, do all the cabling, then boot it all up just to run these LLMs. And they're running out of space. I don't think they can build them quick enough. And I also saw some tweets about they're going to start launching them into space and doing like solar.
I think Microsoft had a test where they ran data centers underwater for the cooling. What you were just saying like made me think, if you're if your company is expanding, as in like growing exponentially, or let's say 100% year on year, there's no way you can keep up with hardware on your own. Because I was thinking, let's say I order 10 racks in the first year and I build them and I start using them. But next year I'm going to need 10 more. And the year after I'm going to need 20 more and so on. There's a physical limitation on where you can put those racks in a data center, right? So that means I might have a scattered rack layout, which makes it almost impossible or very expensive to run because I have to cable longer distances between my own racks that are scattered across the data center.
That's not so much of a problem. But it's more, then you have, when you want to take care of this, you have to go around all to different floors and stuff. It slows down the engineers. But in that case, these bigger companies that rely on hardware, usually they will provision a whole new suite way before they need it. But there's a massive capital investiture in that.
Yeah, so you have to pay for the space for the future servers.
And as you were talking about that, it made me think it's a lot more waterfally. The way of working, you plan way ahead. And then you invest now, or you build, and then you cannot adapt. It's like you're locked in for that period.
What I could imagine, on the contrary, to well-established businesses with very stable workloads, year on year, it's always the same, and you are fighting the margins. You have a small profit margin, and you want to shave off another %, let's say, on your OPEX. This could be a way to actually reduce your cost slightly, if this is, let's say, a decade-old business that is quite stable. I'm thinking financial systems, payment systems that will not go away anytime soon.
Sure.
It might be worth the investment.
But I don't see how. Because, like, you're going to have to pay 3 people to run these things. And
large-scale companies.
And then every 3 years you have to replace everything. And then I don't see it being cheaper.
Yeah, you can see that we're making mental exercises to find excuses to run your data center.
Yeah.
But in reality, it's very rarely the case that you would need to do that.
And every time that someone argues for it, they're not thinking about the hidden costs of or missed opportunity costs, the amount of time and effort it takes the person to manage all of this stuff when they could be managing something else that's more important. There's so many hidden costs involved with running a data center. And I don't want to be, we are coming across as data center haters, but I think that comes from experience of us having done this a lot. Yeah. But I like in the world, it's like, what's a good analogy? I like beef, right? I like eating beef, but I'm not going to grow a cow every year. Or if I did want to grow a cow every year, it would cost me a lot of time and effort. Or there can be a big farm down the road that grows 1,000 cows, and I just buy the meat, buy one cow off them a year in frozen form. Which one is more efficient? It's always going to be the efficiency of scale. That's why Amazon makes so much money, is because they delivered a very efficient product and they can charge for it because it saves you so much time and effort.
Yeah, I agree. Okay, but then what does it mean for people who are network engineers or operations guys? Does that mean that going forward, pretty much the only place where they can find a job is these big companies?
No, well, maybe go work for an AI company. They're going to need 7 million data centers. You can work for them. Data centers are never going away. Like, unless we invent some form of, like, I don't know, new matter that can store information in a different dimension or something, we have to have compute to support modern life. There's always going to be data centers. There's always going, well, not always, but like for the foreseeable future, there will be data centers, and there will be a requirement for network engineers and hardware engineers and these people taking care of them. There's so many jobs out there for these people. What we're talking about now is, as a software engineering company or a company that does something else, do you want to run that yourself? No, because you're not a data center company. You're not a compute provider. That's the differentiator here, I think. So these people, they will always be able to find jobs.
Yeah, and I've seen many network engineers who transition into the cloud, and they can bring their own knowledge about networking into the cloud, because cloud is just like an abstraction layer on top of the network. So if you understand what a network does, you will understand the concepts. Now, every cloud provider rebrands everything. It's sort of ridiculous sometimes, but the fundamentals are the same, because it's the same internet, the same network layers below it. So I think it's important to note that the knowledge is transferable to the cloud, and you just have to use different terminology, but it's the same.
I mean, yeah, I would like you. It takes a little while to give up the control. I understand that completely, and to like map your existing knowledge to the cloud. But it is super doable, and it is very valuable to some companies, especially if you haven't designed a good cloud network from the outset. It takes a lot of time and effort to re-engineer it back to a good one. Do you know what I mean? And having a good understanding of the networks is very valuable even in the cloud space. I agree. Same with sysadmins. Like, there's always going to be people that need automate EC2 images that are configured in specific ways. You just need to transfer your knowledge over to these other things as well. It's just different ways of wiring stuff. I still think, like, I'm doing DevOps for a company at the moment, and I still think of it in like a network way, because I'm just wiring things together, but it's more abstract than that.
Yeah. All right. So I think like we gave a good overview of how those data centers
it's super rambly. Yeah.
No, but I think because we touched on a lot of topics that most people will never be exposed to, never have been, and in the future definitely won't be. So I think it's a good insight in what goes into running your own data center. And of course, we generally don't advise to do that, but if you have to, at least you know like where to start or like how to think about this or what to consider.
Yeah.
I think it was a very good insight into this world.
I think,
thank you.
It's it's one of the places where the old adage, proper planning prevents poor performance, is super valuable because of it costs so much to get. The burden of entry is super high, barrier to entry.
So barrier to entry is high. Fixing mistakes very costly. It takes years to change the internal architecture of a data center presence if you grow out of it. Well, it is hardware, right? So it's in the name. It's hard to change if you mess up.
And I mean, if you've ever had problems with like your Wi-Fi or your computer not doing what you want, it's that times a million, because you have to do it with hundreds of servers. Fun. I want to preface it by saying I'm a bit rusty, so hopefully it was not too out of date. But it's complicated. It's not as easy as people seem to think it is. It's not just plugging a bunch of computers together. There's a lot involved with it. It needs a lot of prior thought and planning. It needs a lot of initial investment, and it needs a lot of ongoing care to keep it running in a nice way. So my summary would be, only do it if you absolutely have to. Make sure you get good people if you do, because they're going to be essentially responsible for your whole product. It's not like they get to offload that to a cloud provider. They're going to be responsible for everything. Yeah, good luck. Use the cloud if you can. That was what.
Oh, thank you.
Okay, nice. Thank you for interviewing me for once, Krisztian, instead of me ranting at you. As always, please, if you need to talk to us, you can email us on techleaguepodcast@gmail.com, and then we will see you in a week. Thank you, Krisztian.
Yeah, and if you're interested in similar random topics, subscribe.
Yeah, like and subscribe. Puss.
Thank you. Puss.
Thank you for listening to the Tech League podcast.